Yeah, now you can start the class.
Yes, sir. Thank you, sir. Right.
Yeah.
So previous week, as I told that, let us start with the problems. So in one single problem, now I'm showing you to how to solve the 5 problems. That means the parameters need to analyze or evaluate is different. The given data is same for all the 5 parameters what I given here. How to calculate soil moisture content by weight basis, on volumetric basis, and also the depth of water in sampled soil depth. That means in given soil depth, what is the depth of water is present? That is the important one parameter. Here in a single problem, that means here you can see you already have done in your UG, that in agronomy first principles course, that weight of the moisture can have analyzed that we have brought the soil samples in the moisture can that have weighed the soil sample, and then plus can what is the weight, and dry soil what is the weight. So here what you want to understand is, in some situation they will not give the bulk density. What I want to say completely is, in all the problems some parameters are they must be analyzed, or they for example they must be how to know that value. For example, soil bulk density they will not be given. They may ask about estimate the soil moisture content on volumetric basis. To analyze the volumetric basis you need that soil bulk density, but it is understood. For example, in red soils what is the soil bulk density, in case of black soils what is the soil bulk density, it will be almost similar but it slightly varies. So on an average you have to know that what is the soil bulk density. So that is the one. Then sampling soil depth, it varies. For example, 30 centimeter or 60 centimeter or 90 centimeter or 1 meter. When they have given 1 meter, you have to convert it for centimeter. Here you have to understood that every unit must be in a single. For example, if it is the moisture can in grams, then everything should be in centimeter or also in gram. It should not be in kg. For example, if they have given in kg, then every parameter you have to convert into kg and also in centimeter to meter. So okay, now let me start. You better you keep one paper and pen so that you can clearly write down this the points, what are all the things you have to know while solving the problems, so that I can clearly explain. Okay, first one is how to estimate the soil moisture content by weight. What is the difference? Here you can see weight of the moist soil, weight of the dry soil, that is 150 minus 40 gram. Yeah, this you will know that weight, you have to minus this moisture can weight, that is wet weight minus dry weight divided by dry weight. There, what is the thing you have to understood is, in the problem solving you should know the moist can weight must be minused with the both moist soil and also the dry soil. In the problems they may give the weight of moist soil plus can as 150 gram, and directly they have given weight of dry soil minus can. They have clearly mentioning that weight of dry soil minus can, they have given 100 gram. So in that case you should not minus the dry soil with the can weight. They have already minused the can weight. So this tricky point some students will lose, because they by seeing these problems they are always thinking that we have to minus with the can weight for both the moist soil and dry soil. But in tricky questions they directly they will give the dry soil minus can. They are not adding this can weight, dry soil minus can. So in that situation you have to be clearly know that what is the what is the question given, moist soil plus can, then dry soil minus can. If it is moist soil plus can, then you have to minus the can weight. If it is dry soil minus can, then you should not minus, you have to take that value as it is. So the formula you have to mug up, that is wet weight minus dry weight into dry weight divided by into 100, so that it will give percent. Always you have to mention the moisture content in percent basis. The question may be like this: soil moisture content is expressed as in units. Which unit? That must be percentage. So second parameter, how to analyze how to calculate the volumetric basis, volumetric water content. So here the formula is wet weight minus dry weight divided by dry weight into 100. Here the only the parameter required is, what do you mean, that is bulk density. Here you can see that the bulk density is the one which we required for volumetric basis. So what I am suggesting is, So whenever you want to solve the problems, even though if they have not given the parameter, for example, bulk density, take it as 1.5. For particle density, take it as 2.6. In general, you have to consider these two factors. If they are given, yes, it is good. If they are not given, you have to consider when they have asked volumetric basis. For dry basis, you should not, you do not require any bulk density. Only thing is dry weight and wet weight. But when it comes to the volumetric basis, you need this bulk density value. So 110 minus 100, this you can clearly mention. But in case of in exams, they will not allow you to carry the calculators. So what they will do, they will cleanly gives the value not in the decimal point. They will give the value, the answer must be in the value that is 25, 30, 35. It will be like that. So you have to be fast while solving the problem, because 110 minus 100 divided by 100 into 100 into 1.5, you clearly remove these two zeros. So then 110 minus 100 is, it will hardly give 10, not hardly hard 10. 10 into 1.5, 15 centimeter per meter. This you have to know. First, you have to solve this type of problems, because if you see this formula, then definitely some people will look after, oh, I need calculator. Don't look after for calculator. It is clearly and it is easily you can understand and easily you can do this. 110 minus 100 divided by 100 into 100 into 1.5. So this you have to know. I want to say is, before solving the problems, you first have this multiples. What is the multiples with 1.5 into 10 or 1.5 into 12, 1.5 into 15, so that it will be easy for you while calculating the problems. Then if water content it is not there, then what is the delta V value? That is a delta W into delta B also gives 15 centimeter. It is not at all required. So next is, after this, what you required is depth of water in soil depth. That is depth of water required in sampled soil depth. What do you mean by sampled soil depth? That means they have taken the soil at a depth of 30 centimeter. That is the sampled soil depth. You all might know that whenever you want to take the soil sample, we will take around 15 centimeter depth. But in some cases, we will take 30 centimeter depth, because that centimeter will vary. That means amount of water, what is the amount of water depth, what is present in that soil up to certain depth, soils or loose soils, what is the depth of water present in that. So in order to know that value, we will take this depth of water in sampled soil depth. Then what is the formula? That is equal to, even when they have given weight basis, when we want to calculate on weight basis, here just we required is delta W, that is what is the moisture content on weight basis, that is per weight basis, then it will give 10 divided by 100 into 1.5. That is what do you mean by delta B is nothing but bulk density. What is the DS is soil depth given. Here only thing varies is 30 centimeter, whether they have given 30 or 90 or 120. So that you have to know. Always you just see 30 into 1.5. It will be similar. That is a delta B. That is the soil depth is almost same for all the soils. 1.5 is considered. Only thing, whatever the answer, 30 into 1.5, 60 into 1.5, what is the value, that you have to mug up the values, because it is same. You need not to multiply in the examination hall, because always we will take the sample at a depth of 30, say 15, 30, 60, 90. So that bulk density is almost same. So what is the value when we multiplied with 30 and 1.5? It should be mug up, and only the value will change here only. That is a 10 divided by 100 it may come, or 25 divided by 100, anything it may come, but this value have to know. So finally we will get a 44.5 centimeter. In case of volume basis, only thing is, if they have given here, you can note down another one question here only. The soil moisture content on volume basis is 15%, and the soil depth taken is 30 centimeter. Then they will ask, what is the depth of water in soil sample? Here we will not require any bulk density, because in order to calculate volumetric soil moisture content on volumetric basis, we required bulk density. In that formula itself, we have added the bulk density. So what you have to do, only thing is 15 divided by 100, because we have given that in percentage basis. So 15 divided by 100 into the soil depth given, that is 15 divided by 100 into 30 will give 4.5 centimeter. Both are same. Here you can expect only this question. That is, what is the soil depth of water in sampled soil depth at 30 centimeter when the percent soil moisture content on the volume basis is 15%. This is clear cut question. So while solving the problem, first you have to analyze what are the parameters given. If they are given volumetric basis, just you have to multiply this volumetric basis percentage into 30 centimeter, as you mentioned 15%, so we divided by 100, it will give 4.5 centimeter. If they have given weight basis, then we have to assume the bulk density. If it is given bulk density, it is well and good. If it is not given, then we have to assume the bulk density of 1.5. Okay, 1.5, the value is 1.5. Then what are the other expected questions in this question? Means in this type of problems is they may give only this weight basis and bulk density basis, and they ask for 15 centimeter or 30 centimeter, but they have not given the centimeter, they will give in meter. So then you have to convert that meter into centimeter. Then we will express this as 4.5 centimeter, because in the answer they will expect in the answer, if they are given centimeter, then we have to convert it to centimeter. Okay, so second question, right? I think any doubts here for this problem?
No, sir.
No, sir.
Clearly understood?
Yes, sir.
Okay, right. Then we will move for second question, right? Calculate the total depth of water in the 60 centimeter soil depth from the following. In the previous class, I have explained what you mean by field capacity, what you mean by permanent wilting point, what you mean by bulk density, all those things. So field capacity in general, what I can say, after 24 hours of irrigation, whatever the water which is removed by the gravitational power, the present moisture that available water to the plants is in field capacity. The permanent wilting point, what is the range, everything I have told in the previous week. So in that continuity, now here the problem is total depth of water in 60 centimeter soil depth we have to calculate. Here don't think that in the question paper this type of question will be there or this much of question will be there. Only here you can see the depth may be 0 to 15 centimeter. They may ask for only 0 to 15 centimeter, or may they ask 15 to 30 centimeter, but the units are same: field capacity, permanent wilting point, and bulk densities they have given. The question will be like this: calculate the total depth of water in the 60 centimeter soil depth which is having field capacity 24%, permanent wilting point 9%, and bulk density 1.30 gram per cm cube. So what is our formula? Depth of water in each of four depths. If you consider 0 to 15 centimeter, what is the difference in depth? 0 to 15 centimeter, what is the centimeter value? That is 15. That is, I have to take on 15 centimeter. Here, what is the formula in order to calculate the water is field capacity minus permanent wilting point into bulk density into depth of water. Okay, what I have explained here is field capacity minus permanent wilting point into bulk density into that depth of soil. Why we have taken 100 is because we have expressed all these parameters in percent basis. So that's why we have considered here 100. So this is the formula you have to mug up. What is the total depth of water in the 60 centimeter soil depth? Later I will say how to calculate, why to calculate for 60 centimeter, or how to calculate, I will say. Okay, it's now 24 minus 9 divided by 100 into 1.3 into 15, it will give 2.93 centimeter. Okay, so can you please calculate for another 1 centimeter, that is 15 to 30, so that I can say yes, you are alert or something like that. By using the same formula, you take the depth of the soil and you calculate now itself, so that it will be easy for you. It will be some doubts will be clarified. By seeing the class is different from calculating the formula. So once you try, whoever the people who are having the paper or pen, so please solve this problem now itself, so that you will have some questions. Sir, how to calculate this one or that one? Why we have to consider only 15 centimeter? So that it will be known, right? I'm giving 1 minute time, so whoever is possible, you can solve.
Sir, 6.075 centimeter.
How much?
6.075.
Sorry, you have taken around 30 centimeter soil depth. Huh?
Yes, sir.
Yes, that is the wrong. That's why I told you solve the problem. Yes, right. Whatever
Okay,
the same doubts will be arise. So that's why I told you to solve the problem. Okay. Some other answers? Any other answers?
Sir, 7.08.
How much?
7.08.
You have considered how much that soil depth?
15 centimeter.
Then field capacity minus permanent wilting point into 1.35 have taken.
Yes, sir.
Then divided by 100 you have done.
Yes, sir.
How much you got? 7 point something. Huh?
Yes, sir.
Sorry, check once again.
Okay, sir. Okay.
Okay, right. Not an issue. You can check that is because this is the learning time. Okay. Okay. Now I will say, see here, what is the issue is answer is 3.04 centimeter. You can check here. So some students will miss
Yes,
this.
sir. Yes, sir. Yes, sir. 3
Yes.
point something. Aage, sir. Thank you.
Okay. Some students will miss here is they are going to consider the depth of soil is 30 centimeter. Here they have given the range of 15 to 30. What is the difference from depth of the soil? 15 to 30 is only 15. If they have given 15 to 45, then what is the difference is 15 to 45, 30 centimeter. Then you have to consider here 30 centimeter. But here what you have to take here is 15 centimeter only. Because this type of problems you have to know depth. When you have considered 0 to 15 centimeter, you have taken 15 centimeter. Then 15 to 30 centimeter, that range here is 15. So don't miss this point. Don't consider as 30 centimeter. You have to consider as 15 centimeter. Clear? Okay. Then third depth also you have to consider 30 to 45. What is the difference is 15 centimeter only. Then again 45 to 60 centimeter. So 15 centimeter only. So at first 15 centimeter, what is the amount of moisture is what is the depth or amount of depth of water is 2.93 centimeter. That means for 15 centimeter depth of soil, the amount of moisture present is 2.93. Then again from 15 to 30, below that, for that 15 centimeter depth, again the amount of soil moisture depth is 3.04. In order to calculate for 60 centimeter, that means first 15, second 15, third 15, fourth 15. The total here is 60 centimeter. The question here is the total depth of water in the 60 centimeter soil depth. That means we have to add all these things 2.93, 3.04, 2.94, 3.36. So what is the answer? Total you calculate that that will comes around 12.27, I think so, 12.27 centimeter. Here what is the question what you can expect? This is the basic thing you have to understood, that is the depth and field capacity problems. But in case of JRF, what they will give is they may ask only this depth, first depth 0 to 15 centimeter, or what they will give, calculate the total depth of water in the 60 centimeter soil depth from the following, or they will give from first quarter or from first quarter, that is 15 centimeter is 2.93, from next quarter is 3.04, from third quarter it is 2.94, and from fourth quarter 3.36. What is the depth at 60 centimeter? It is simple question. It is a simple, that means if you once you look this type of problems, it will be simple. But without knowing this type, without knowing this basics, if you look in the JRF question paper, then you think that I have not solved this type of problem, I don't know this type of problem, this is too much tricky. There is no tricky, only adding all these quarters, that is 2.93, 3.04, 2.94 and 3.36. Addition of all these quarters will give the amount of total water depth in 60 centimeter depth of the soil depth. So what I am focusing here is they may give this part. That means they have given these parameters and you have to calculate only first quarter, or they may give all the values of 4 quarters. They may ask for 60 centimeter soil, sorry, 60 centimeter soil depth.
Excuse me, sir.
Ah,
Sir, what if they didn't give us bulk density? then हम क्या assume करेंगे उस time पे?
Yes, 1.5. If they have given, if they have not given the, what is the normal bulk density value, BD, on an average?
So 1.5.
Yes, yes, okay. What is the particle density?
Hmm.
It is around
I don't
2.6. Okay. If they have not given the bulk density value, then you have to consider as 1.5 only, right? Why they, while the problems, if they have given the different depth, they will definitely, surely they will give the bulk density, because bulk density will vary from depth. As you all know, the bulk density always varies from the depth. From inner depth, there will be more compact because there is no disturbance in the soil. The bulk density, because of this compactness, the bulk density, see here you can see at the surface of the soil, the bulk density is less, 1.30, because but at the deeper depths, the bulk density value is 1.60. That means the bulk density is increasing. This is not an issue now, but I am saying is in general you have to consider 1.5 for bulk density, and I will say, I will give all data what are the normal consideration if they have not given the parameters. I will say not only the bulk density, particle density, some moisture contents are there, some infiltration rates are there. Finally, when that problem will comes, I will say, I will explain. Okay, right. Now you got this problem, how to solve this?
Yes, sir.
Yes, sir.
Okay, any doubts? Any doubts for solving this problem?
No, sir.
Okay, right. Can we move? Can I move for next question?
Yes, sir.
Okay, right. Okay, now calculate the soil moisture percentage as I explained in first question. Similarly, now the soil bulk density and also the depth of water per meter depth of soil. Here, soil moisture content is same, soil moisture percentage what I have explained, the similar pattern you have to analyze. But what you have to concentrate here is how to calculate this soil bulk density. In the previous problem, I explained you how to calculate soil moisture percentage and how to calculate the depth of water per meter depth of soil. But in present now, how to calculate soil bulk density. Here, what are these parameters? What they have given? I think you all worked about infiltrometer, right? In that infiltrometer, what is the height of the core sampler? The height of the core sampler is 20 centimeter. Inside diameter of the core is 8 centimeter. Then weight of the core sampler plus moist soil is 3 kg. Weight of core sampler plus dry soil is 2.8 kg. Weight of core sampling cylinder is 1.5 kg. If you think that this much of lengthy question, if they are not give, they may not give in the jar of paper. But my friends, don't think like so. Don't think like that, because in some, I think in 2018 they have asked this type of question in soil science also and also in agronomy by giving different type of values and different type of parameters. I will explain how they will give the question. First, you have to understand the basics. What do you mean by height of this core sampler? You all know the concept of infiltration. So what is the infiltration? It is the inner movement of water from different layers, from uppermost layers to below layers. That is the one. How to calculate that infiltration is that the instrument is, that is here the core sampler is there, height of the core sampler. What is the height of that cylinder is 20 centimeter. Inside diameter of the core is 8 centimeter. Then core sampler weight plus moist soil is 3 kg. Weight of core sampler plus dry soil is 2.8 kg. Then weight of core sampling cylinder is 1.5 kg. Okay. What is the formula to calculate soil moisture content? Earlier what I have explained, that is moist soil core sampler, we have to minus this core sampler weight, that is they have given 1.5 kg. Moist soil is 3 kg minus 1.5 kg, it will give 1.5. 2.8 minus 1.5, that is dry soil minus sampling cylinder, it will gives 1.3. So 1.5 minus 1.3 divided by 1.3, that is wet weight minus dry weight divided by dry weight. Okay, in the examination, if you got confusion whether I have to put first dry soil, dry weight of the can, or wet weight of the can, my friends, always in the formula while calculating the soil moisture content, first we will take the observation of wet weight only, not the dry weight. After dry only we will take dry. So first observation will be wet weight, because always the value will be higher. In order to calculate the amount of moisture present in that soil, we have to minus from the wet weight to dry weight. Don't confuse that whether I have to put first dry weight minus wet weight divided by wet weight or wet weight minus dry weight. My friends, always you have to consider wet weight first. So wet weight minus the dry weight. In simply I can say is higher value will always comes first, then the lower value. So 1.5 minus 1.3 divided by 1.3 into 100 will gives 15%. That is the soil moisture content. So how to calculate soil bulk density? In order to calculate soil bulk density, first we have to calculate core volume. That is here the formula pi r square h. It is the volume. It is the formula to calculate the core volume. That is, what is the pi value? The pi value is 3.14. What is the radius? How you have to calculate radius? Here they have given the diameter 8 centimeter. So 4 centimeter will be the radius, r into r. Then height, what is the height of the core sampler? That is 20 centimeter. My friends, in the entire problem, they may give soil moisture percentage for JRF questions. They will definitely ask this bulk density for SRF questions and ASRB questions for net preparations, because this bulk density calculation itself is an applied question. So in order to calculate bulk density, you have to know this formula, that is pi r square h. This we have to mug up. This general formula. What is the, in order to calculate the core volume, we have to look after this formula, that is pi r square h. That is 3.14 into 4 into 4 into 20 will give 1004.80. Here in general, what they will give, the answer is not only they will give exactly, they give 1004, they will give 1000, 1500, 2000, 2500. If you are having the idea already solved by this problem, then definitely without calculating you can put off this question as 1000 only. Don't look after that it may give 1004 or they have not given the 1004 option, but when calculating I will get only 1004, because here not the pi value will always not be 3.14. So by considering that part, they will give 1000 only, 1000 cm cube. So if you solve this problem earlier, you can directly mark as 1000. The radius will be constant, then and also the height of the core sampler is also constant. Then why you want to solve the problem in the question, that is in the exam? Directly you can go for this answer, that is 1000 cm cube will be gives the bulk density of that core sampler, right? Then what is the formula to calculate bulk density? That is, bulk density will give, that is 1.3 weight of the dry soil minus bulk density we have to consider, that is the core volume we have to consider. 1004 on an average have taken the first have 1.3 minus 1000 divided by 1004.8. Here have to consider 1004.80 cm cube is my value, that is core volume. That will give 1.29 gram per cm cube. That is 1.3 minus 1000. Then what is that? What is that? Core volume value is 1004.80 cm cube. This you should not remember, or this will not ask in the exam, because this is too much clumsy for solving without calculator. 1.3 minus 1000 divided by 1004.8, definitely this will not ask in the exam, because this is complex and you can't calculate without calculator. So direct questions or direct value only they will give. What you can expect is, here this one you can expect how to calculate core volume, this formula and this one. So this you have to mug up. That means this formula pi r square h you have to mug up. Okay. Then how to calculate this depth of water? How to calculate this depth of water per meter depth of water? Earlier I explained that what.
Excuse me, sir.
Yes, yes.
सर ये जो आपने ऊपर 1.3 माइनस 1000 लिया, ये जो 1000 है आपने एज अ रफ एस्टिमेट लिया 1004.8 का.
I'm not getting. Hello. Yes.
Sir, in this question, soil bulk density 1.3 minus 1000. ये जो 1000 है ये कौन सा यूज किया आपने?
So here for considering, for example, the always soil bulk density will be calculated in general while calculating gram per cm cube. Here that is cm cube. Here you can see cm cube, that is centimeter into centimeter into centimeter, right? So that will give 1000, right? That's why we have considered for 1000 here. The unit normal, the bulk density 1000. So that's why here we have considered. And the core volume, what we will get, that cylinder value, here we will consider for 1004.8, right?
Okay, sir. Okay.
Okay, okay, right. Then what is the depth of water per meter depth of soil? Here, how to calculate this depth of water per meter depth of water? Here we are considering 15. What is this 15? This is the soil moisture percentage. In order to calculate the depth of water, first we will calculate 15 meter, 15 percentage. In while we are representing in percentage, we will consider 15 divided by 100 into 1.29. What is this 1.29? This is the bulk density value. This is similar question as like in first question, that is they have given here this weight basis, soil moisture percent on weight basis multiplied by depth of the soil, we will get this depth of water. And I calculate now how much the depth of water will comes. I have already given the answer, 15 divided by 100 into 1.2, I calculate it.
So 0.119
Yes, the unit.
unit is I guess centimeters.
No. When you multiply that one with 100, you will get centimeter. 0.19 meter. It's in meter only, right? Okay.
Okay, sir.
Okay. When the answer is 19 centimeter, when the unit is, if you get 0.19, it will be in meter only. When it is multiplied with 100, you will get 19 centimeter. So you have to express in centimeter or meter, whatever the answer, whatever the given in that options, you have to consider that. Then you have to mention in that format only. Okay. So right. Then let us move for last problem of today's session. Okay, right. This is the one which is very important problem. Here you have to see how to calculate field capacity and permanent wilting point as percent volume basis, and how to calculate available soil moisture, how to calculate this bulk density, right? Okay. 3 days after irrigation, soil moisture content at permanent wilting point. Volume they have given on volume basis, that is cm cube. Then wet weight of gram. They have wet weight given that gram, and dry weight is also in under grams only. When you what do you mean by wet weight, gram, and dry weight? That is whenever the soil samples have taken from the moisture cans. This is the one. That is 195. 3 days after irrigation. They are mentioning that the field capacity will be attained by the soil after 3 days only. In general, we will say 24 to 72 hours, the field will attain the field capacity. They are clearly mentioning that 3 days after irrigation, they have attained this something value. So soil moisture, what is the soil moisture at permanent wilting point? They have given the values. Okay, right. How to calculate the field capacity? What is the formula? That field capacity, soil moisture content is here 3 days after irrigation. What is the wet weight minus this dry weight? You have to calculate, that is 195 minus 154. You will get around 41 gram or something. Field capacity and volume basis, that is 41, whatever we will get this soil moisture content 41 divided by 114. Here when we want to calculate on volume basis, the answer they have already given parameter is 114. Just we have to divide it. 41 divided by 114, it will give 36%. You need not to concentrate this part. On volume basis, normally they will not ask. Only the soil moisture content at field capacity they will give on the weight basis, that is 195 minus 154. This part you have to consider, that is 41 gram. Okay, this is field capacity. That is, what do you mean by field capacity? Wet weight minus dry weight. That is the formula. Wet weight minus dry weight will give the answer of field capacity. You need not to mug up almost all the formulas. I didn't see the formula of how to calculate field capacity. I know that only the formula of field capacity, or I know only the definition of field capacity. I don't know. Don't think like that. First you have to understood the basics, then you can easily solve the problem. What do you mean by field capacity? It is the wet weight minus dry weight will give the field capacity. Okay, then at permanent wilting point, that soil moisture content is 208 minus 118. That is soil moisture content at permanent wilting point. 208 minus 118 will give 20 gram or something. Permanent wilting point on a volume basis will give 14.4%. Okay, right. Our major concern is how to calculate this available soil moisture. You please mark this one. So how to calculate this available soil moisture? That is field capacity minus permanent wilting point will give the available soil moisture. Okay, 36 minus 14.4 will give 21.6%. In JRF question, they will give like this. Calculate the ASM. They will not also give full form. They will give only ASM, available soil moisture, when the soil is having moisture at field capacity is 36% and soil moisture at permanent wilting point is 14.4%. What is the available soil moisture? It is a simple question. To calculate available soil moisture, we have to minus this field capacity minus permanent wilting point, that is 21.6, that will give 22 centimeter per meter. Then how to calculate this bulk density? Now this is the question, how to calculate here the bulk density. Earlier what I explained in the previous, bulk density at field capacity is different and bulk density at permanent wilting point is different. So what is the formula is, bulk density means dry weight divided by volume. What is the volume they have given here? 114. What is the dry weight they have given here? 154. That is the bulk density. 154 divided by 114 will give 1.35 gram per cm cube. But what is the bulk density at permanent wilting point is 188 divided by 139, that is 1.35 gram per cm cube. Here the one and most important point what you need to understood is our calculation of available soil moisture. You need not to concentrate on bulk density at field capacity, bulk density and permanent wilting point. You forget these things. You only concentrate on available soil moisture estimation when they have given field capacity moisture content and permanent wilting point percentage. In examination hall, you will get confused with whether I have to consider this 36 into some other units. That means they have given in percentage basis. What I have to express? Whether 36 divided by 100 I have to do or 36 divided by 1000 I have to do. This type of doubts will be arise in the examinations only. So before going to that, you need to do or you need to work out this type of problems. Then you will know whether where you have to convert into units, other units, or where you should not convert. Here there is no conversion is required because available soil moisture will be expressed in percentage only. That means you need to require these units in percentage only. There is no requirement for conversion into divided by 100 or something like that, because some students are having thoughts that if they are giving in percentage, then we have to divide it by 100. Then for 14.4 percentage also we have to divide it by 100. No, it is not required. Here whatever the required is 36 minus 14.4. That means whether the required answer, if you want in percentage basis, means then we need not to convert it into any units. We just directly minus it. That is 36 minus 14.4 will give 21.6. So these are the basic questions what I have explained in this previous topic. So how to calculate what I explained about field capacity, permanent wilting point, then bulk density in the previous class. So these are the basic questions. This type of questions will be there given in lengthy type. So you need not to worry. You just take these problems and just solve it and make a note on some other pages or in the back side of your notes, so that it will be helpful. After reading the topics related to available soil moisture, field capacity and permanent wilting point, just go through these problems or just to solve these problems. Then you will get a clear idea how to solve the problems if in the examination if they are given. So in the next week, Next, I will take some other points, that is theory point. If it is possible, the theory in the theory itself, I will solve the problems, or I will take the theory part next week, and afterwards I will take the problems. Okay. So I think any problems in this no, solving the problems, you can directly ask me, or still you want different type of problems. Definitely, I need to know what are the different type of problems you want to solve. So in some competitive examination books, they may ask different questions. If you find anything problem is solving the that questions, just WhatsApp me, so that if I find a time, I will definitely solve, and I will discuss with you in this class itself, or else I will personally text you. Next week already one person they have I think Sharma, she has I think I don't know, she has sent some problems. Next week I am going to discuss that those problems. So surely it will be discussed. So any problems related to irrigation, not only irrigation, any problems, if you find difficulty in solving the problem, just text me. In the class we will discuss, right? So any problems here for discussing any problems, or you need some other problems, let me know, right? I'm giving the time
सर
for you.
सर आप जनरली वो प्रॉब्लम्स पुट अप करो जो एग्जाम्स में आ रही है.
These problems, huh?
हाँ सर, जो प्रॉब्लम्स एग्जाम ज्योग्राफी एग्जाम्स में आ रही है वही प्रॉब्लम्स आप डिस्कस कर दिया करो ज्यादा कर जो आती हैं.
No, this type of problems will only come in the examinations.
यस सर. ओके.
Okay. Okay. Oh, that means you are saying that whatever the problems expectation from the examination part point of view, I have to solve it, right? Okay. I will do the same. Okay. Any more suggestions? Suggestions are required.
Sir, can you share this PDF, sir?
Yes, Vardhan, right.
Sir, can you share this PDF, sir?
Yes. I will share in this group, WhatsApp group. Okay.
Okay, sir.
Okay, right. If you
Sir,
are
and
having
also give some practice problems, sir.
practice
If
problems,
possible. Yes, sir.
definitely I will give. Definitely I will give. Right. So this is
Yes,
the
sir.
first class for solving the problems. In next class, please be ready with the paper and pen, and you need to be alert with the calculations. For example, what do you mean by what is the 12 into 12, 11 into 11, 10 into 10? So you need not to go for calculator. In mind itself, you have to calculate. So please mug up the tables so that it will be easy for you in almost all the problems, right? Okay. Right, guys. Thank you, Anandal. Bye. We will meet you in next class with the theory part.
Okay, sir. Thank
Okay.
you, sir.
Right. Bye.